The molding of plastics is a common method of manufacturing parts and encompasses a variety of processes, with the principal type being plastic injection molding. Injection molded parts are produced from two types of plastics, thermoplastics and thermosets. Of the two types of materials, thermoplastics are the most predominantly used. In injection molding, molten plastic material is injected at high pressure into a mold containing the form of a part. Once this plastic cools and solidifies, the mold opens and the part is ejected. Once molded, most parts require additional processing, such as assembly, for completion. But many plastics finishing processes are performed for aesthetic or appearance purposes. These finishing processes are the primary focus of this program and include degating, deflashing, cleaning, and decorating. Virtually all plastic products require some decoration. The methods of decorating molded parts include molded-in decorations and applied decorations. Molded-in decorations are those machined into the mold, such as textures, or by implant, as with two-shot molding, where an insert is placed into a mold and then molten plastic is injected around the exposed areas of the insert, creating the part. Even pre-colored plastic resins are considered molded-in color. Applied decorations are added to the plastic part after molding. The most common types of applied decorations include painting, plating, vacuum metallizing, pad printing, hot stamping, silk screening, fill and wipe, and others. Liquid paints may be applied to plastic parts for many reasons, but usually to ensure proper color matching between adjacent plastic and non-plastic parts, as on an automobile. As with any finishing process, surface or substrate preparation is a critical step. Surfaces must be absolutely clean and free of any contaminants. This helps ensure adequate paint adhesion to the plastic part. There are a variety of paints available for use on plastics, including epoxies, polyurethanes, enamels, acrylics, and latexes. Paints are applied to plastics using many methods, with some of the most common including conventional air spraying, high-volume, low-pressure spraying, and flow coating. Conventional air spraying uses highly compressed air to atomize the paint, which is applied using a spray gun. The paint is fed to the gun through either a gravity, siphon, or pressure system. The paint may be applied manually, semi-automatically, or automatically. High-volume, low-pressure, or HVLP spraying is an air atomization system that uses less than 10 psi, or 69 kilopascals of air pressure to apply paint. HVLP spraying produces a softer, more controllable spray, reducing overspray and paint wastage. In a flow coating system, a number of individual streams of paint are directed at the plastic part. Excess paint is collected as it drains off, where it is pumped through filters and recirculated for reuse. Once a paint coating has been applied, it is transformed into a finished solid paint film by curing. Depending on the coating, curing can occur at room temperature or within an oven. Plating is the chemical or electrochemical deposit of a thin metal layer to the surface or substrate of the plastic part. Plating requires the plastic parts to be electrically conductive. To achieve this conductivity, the plastic parts are first subjected to an electroless plating operation. Plastic parts are prepared for electroless plating by submersion in a sulfuric chromic acid bath. This acid slightly etches the plastic substrate surface, creating microscopic pockets or pockmarks. After etching, the plastic parts are placed in an activator bath and an accelerator bath. These baths line the pockmarks of the part surface, making it chemically attractive to the metal suspended in the electrolysis plating bath solution. As the part sits in the electrolysis plating solution, the nickel and/or copper deposit and become trapped in the pockmarks. The time in and the temperature of the electrolysis plating bath determines the thickness of the metal layer. Afterwards, the parts are electrically conductive. Electrolysis plating provides a dull metallic finish and often is applied to plastic products used in shielding applications. But electrolysis plating is also the first phase in the electrolytic plating process, which provides a decorative bright chrome finish. Electrolytic plating uses electrical current to draw or precipitate positively charged plating metals out of solution to coat the negatively charged conductive plastic part surface. The positively charged plating metals are referred to as the anode, and the negatively charged plastic part, the cathode. To arrive at the final chrome-plated finish, plastic parts must go through a minimum of 12 preparation, plating solution, and rinse baths. The various plating solution baths include a bright copper plating bath, a bright nickel plating bath, and the final chrome plating bath.